Hello everybody. In this video I am going to show you some of the example from chapter 8, which is friction. Okay, so here is problem number 8-2. You can see here the problem is saying that the tractor exerts a towing force T equal to 400 pounds. Determine the normal reaction at each of the two front and two rear tires and the tractive frictional force F on each tire needed to pull the loaded forward at constant velocity. The tractor has a weight of 7,500 pounds and the center of gravity at GT here, this is 705,000 pounds there, and an additional 600 pound load here. Okay, so basically they are trying to take the frictional coefficient here is 0.4. The front wheel are free to roll. Okay, when something is allowed to roll, then basically there is no friction there. Okay, but let's say the brake is applied here, so it's not rolling, it's just trying to skid here. Okay, so if I draw the free body diagram here, then basically you will see there is a normal force here, let's say 2 NB. Why I'm putting 2? Because there is one wheel this side, the other wheel at the other side. Okay, so for each of them is NB. Okay, for two of them 2 NB. Similarly, I can say the normal force here is actually 2 NC. Now you can understand that this one is allowed to roll, so there is no frictional force, and if this one try to go this way, then a frictional force will develop this way. Okay, let's say this point is actually B. I took that point off from here. Okay, so that's the free body diagram. Basically you can see one normal force here and one normal force here, and since this one is not allowed to rotate, means like the brake is applied there. So we are trying to find out like, hey, what would be this NC, NB and F. So we have three unknowns here and we have three equations, so basically we'll be fine to find out these unknowns here, right? So let's take a moment at point B. So summation of moment at B let's clockwise, counterclockwise is positive. So you can see, take a moment, then this one is counterclockwise, right? 400 into 2.5. Then this one is clockwise, minus 75 into 5, minus 600 into 7 plus 5, 12, and 2 NB, that's actually going like this, so counterclockwise. Multiplied by 9. Okay, so if you solve that equation, basically you will get your NB from here. So your NB is equal to 2427 pounds. Okay, Now if I take the summation of Fy and upward is positive, so you can see this plus this is equal to this plus this, right? So 2nc plus 2nb minus this equal to 0. I already know the value of nb, so I can plug that one and find out my nc, which is basically 1622 pounds. Okay. Now if I take the summation of fx, then basically I can find out that f here. Okay, basically let's say this is 2f. So for each of the tire is f. So I have two tires, one here and the other one the other direction. So there is 2f here. So we can say 2f minus 400, that's equal to 0. So f equal to 200 pounds. Now definitely we have to check that whether f could be 200 or like less, because we know the maximum f max is equal to mu into normal force at that point. Okay, so if you see my mu is here 0.4 and the normal force at C is 1622, that's actually 648 pounds. Yeah, so my F max could be as high as 648. So basically this 200 pound is fine. Okay, so the frictional force when he's applying 400 pounds, then basically the frictional force in each of the tire would be 200 pounds. Okay, at the same time the normal force at B would be 2427 pounds and the normal force at NC should be equal to 1622 pounds. Okay, let's move forward. Problem number 8-8. This one is saying that block brake consists of a pin connected lever and a friction block at B. So that's your friction block here. This one is trying to rotate this one, and this one is the brake, applied brake. Now the coefficient of static friction between the wheel and the lever is mu s 0.3, and the torque of 5 Newton meter is applied to the wheel. Determine if the brake can hold the wheel stationary when the force applied to the lever P equal to 30 Newton and P equal to 70 Newton. Okay, so we have to first see that how much force you need to apply here and what would be the frictional force here. So I try to draw the free body diagram here. This is the free body diagram of the wheel. You applied 5 Newton meter load, and then this is the point B here. You can see there is normal force working NB, and that would cause a frictional force because this one is rotating this way. And I tried to draw this one separately here so you can see the equal and opposite force. This is FB, this is FB, this is NB, NB, and when you put them together, actually you don't see any load there, right? You don't see any load there. So equal and opposite force here, and then you can solve this one and this one separately, and try to see whether this applied force would be able to break that one. Okay. Now let's see actually how much load I need to stop that one here. Let's say if you take a moment at, let's say this is point O here, okay? So summation of moment at O, let's say counterclockwise is positive, is equal to 0. So you can see this NB is passing through this point center. So FB, actually 5 minus FB multiplied by the distance 0.15, that's equal to 0. So you can see your FB would be that's actually 33.33 Newton. Okay, once we get that FB value here, then we'll try to find out what would be the normal force here, right? We know that your FB is basically mu B into NB. So your NB here is equal to FB divided by mu, and you know that mu B is the coefficient of dry friction between the wheel and the brake pad, okay? So which is 0.3 here. So if you put that one here, that's basically 1.1 Newton, okay? Now if you think about this part here, let's say I'm not talking about this part anymore, I'm talking about this part here. Because I already got my NB, I already got my FB here, okay? So if I take a moment here, okay? If I take a moment at A, so summation of moment at A, so let's say counterclockwise is positive. So you can see from here to here P into 0.6. Then NB, which is negative, NB multiplied by 0.2. And then you can also see that AB is also working, which would be counterclockwise here. So plus 33.33, and the distance from here to here is 50 millimeter, so that's actually 0.05. That's equal to 0. So your P is equal to P required. P required to stop that one would be 34.26. Okay, I need 34.26 Newton force here to stop this rotation here. Okay, now they are asking, like, if you apply 30 Newton, then basically you will be able to, whether you will be able to stop that one. Definitely no, because I need 34.26, and 30 Newton is definitely less than that, and it won't be able to stop that one. The second part is asking like if your P equal to 70 Newton, then whether you will be able to stop that one. Well, 70 is much higher than 34.26, so for 70 Newton, if you apply 70 Newton load, then basically you will be able to stop that wheel. Okay? Let's move forward. Problem number 8-15. Okay, this one is saying the log has a coefficient of static friction of 0.3 with the ground and a weight of 40 pounds per feet. If a man can pull on the rope with a maximum force of 80 pounds, determine the greatest length L of the log he can drag. Okay, so you can see the figure here. This is my log, which is L feet, and the weight of this one is 40 pounds per feet. Okay, and then this guy is pulling with this rope with 80 pounds. Now you can see I tried to draw the free body diagram here. So if you see, this is the same rope here. So this one also has 80 pound force. Similarly, if you see, this one also 80 pounds and this one is also 80 pounds. So if I make a cut here, then basically you can see this is 80 pound, 80 pound, 80 pound, and 80 pounds. Okay, so let me draw that one little elongated here. And if I make a cut here, then basically you will see, since they are same rope, so all of them are 80 here. Okay, and then you can see I have this one is 40 L. That's the weight of this log. Okay, now you can see here that's the normal force, and this is your frictional force here. Okay, so you can see from the summation of Fx, so you can see 80 plus 80 plus 80 plus 80 minus F equal to 0. Okay, so you see your F is basically 320 pounds. Now the maximum, like when he is applying 80 pounds load here, actually he can overcome 320 pounds of maximum, like I'll just put that one max here because that's the maximum he can pull, right? So you can see if your F max equal to 320, so your N would be equal to F max divided by mu. So 320 divided by 0.3. Okay, so that's basically your N, which is basically equal to 40 L, right? You can see here, if I take the summation of Fy, then basically N minus 40L is equal to 0. So 40L is equal to N. We know N equal to 320 divided by 0.3. So your L is basically 320 divided by 40 into 0.3, that's actually 26.7 feet. Okay, now let's move forward. Problem number 8-24. Okay, this one is showing here in the figure. You can see that a uniform thin pole, this is uniform thin pole, which is 26 feet here, and a length of 26. It is placed against the smooth wall. This is a smooth wall, and on the rough floor at a distance d equal to 10. From here to here is 10 feet, okay? Will it remain in position when it is released? The coefficient of static friction here is 0.3. Let's try to draw the free body diagram here. So this one is the normal force here and frictional force here. And since this is a smooth surface, so you have only the normal force here, no friction, okay? And this one is working at the middle, so you can see here is 5 feet and 5 feet because that's the middle of this 26 feet. You can also see from Pythagoras formula that if this is 10 and this is 26, then this one has to be 24 here. Okay? Now if I take a moment at this point here, let's say A here, so summation of moment at A weight of this one is 30 pounds. So this is 30 pounds here. So 30 multiplied by the distance from here to here, which is 5. Okay. And this one is minus NB multiplied by 24 equal to 0, so your NB is basically 6.25 pounds. Okay, now I can take the summation of Fx and Fy and find out the other two forces here. So summation of Fx equal to 0. So NB minus FA. So FA equal to NB equal to 6.25 pounds. Similarly, we can take the summation of Fy so NA minus 30 equal to 0, so NA equal to 30. So if NA equal to 30 and the coefficient of friction is 0.3, so F max would be NA into mu A, so 0.3 multiplied by 30, that's actually 9 pounds. So this one is actually higher than your FA, which is 6.25. I need only 6.25 to state that one here, and the surface offers up to 9 pounds. Okay, so this means like this thin pole will be able to um, stay like this. Okay, so it's stable. Let's move forward. Problem number 8-30. Okay, this one is saying the two blocks A and B have a weight of 10 pounds and 6 pounds here. They're resting on the incline for which the coefficient of static friction for A is 0.15 and for B is 0.25. Okay. Determine the incline angle theta for which both blocks begins to slide. Also find the required stretch or compression in the connecting spring for this to occur. The spring has a stiffness K equal to 2 pounds per feet. Okay, so I try to draw the free body diagram here. This is for A. You can see this is 10 pounds here. This is the normal force. This is the maximum frictional force because I'm assuming that both are at the verge of moving. Okay, at that time we are trying to find out what would be the theta as well as what would be the compression or tension in the spring, right? So that's basically the maximum friction here, and this is the force for the spring. And we know that frictional force is basically K into X. K is the spring constant, which is 2 here. So that I just put that value here directly. So this one will be actually 2x here. Similarly, this is the free body diagram for B. You can see this is 6 pounds, and then this force, spring force, is working in this direction, which is equal to x. And this is NB, and you can see the frictional coefficient here is 0.25. So my F max, I can just say this is F max is equal to this. Here is also F max equal to this, because I'm trying to find out all those values when this one is just at the verge of movement. Okay, now let's say this is A, free body diagram A, and free body diagram B here. Now we can just take the summation of forces in x and y direction. But you can see that it would be much easier if you take your x along that line and y along that line, right? So let's say summation of F is, this is my positive direction, okay? So you can see 2x plus 0.15 NA and this one is negative 10 sine theta equal to 0. Okay, so that's equation number 1. And if I take the summation of Fy equal to 0, actually not this direction, that would be this direction, okay? So you can see only I have this one and this one here. So Na minus 10 cosine theta is equal to 0. So you can find out your Na from here. No, actually I don't know the theta yet, so I'll just put that one equation number 2. Similarly, if I go here and write the summation of Fx equal to 0, let's say this is my x direction here. So you can see 0.25 NB minus twice x minus 6 sine theta is equal to 0. That's my equation number 3. And if I take the summation of Fy equal to 0, so NB minus 6 cosine theta, that's equal to 0. Okay, that's your equation number 4. And you can see you have 4 unknowns here, NA, NB, X, and theta. So if you solve that 4 equations here, then basically you would be able to find out all those values, which is theta equal to 10.6 degrees, x equal to 0.184 feet, NA 9.83 pounds, and NB is equal to 5.9 pounds. Okay, let's move forward. Problem number 8-49. Okay, this one is saying the uniform crate has a mass of 150 kg, which is this one here, and if the coefficient of static friction between the crate and the floor is 0.2 between crate and the floor, okay, determine whether the 85 kg man can move the crate. The coefficient of static friction between his shoe and the floor is 0.4 here. Assume that the man only exerts a horizontal force on the crate. Okay, so basically the weight of this one is 150 kg. Here the mu is 0.2 and here mu is 0.4. Let's first try to see that how much force that person can apply, maximum force he can apply before he slips. Okay, so I tried to draw the free body diagram. When he is applying that force here, that the reaction force is coming in this direction. Okay, so you can see his weight is 85 kg, so I just changed that one to Newton. And here is the normal force, and that's the maximum friction force, which is 0.4 N. This is 0.4, the coefficient of friction between his shoe and the floor. Okay, so here you can see that your if you take the summation of Fy equal to 0, you can see N minus 85 into 9.81, that's equal to 0. So your N equal to 85 into 9.81, that many Newton. Okay, so your F max is basically 0.4 of N, which is 0.4 into 85 into 9.81. okay? So if you take the summation of fx, then basically you see your P max so your P max is basically equal to your F max, which is basically 333.54 Newton. Okay, so your P max is also 333.54 Newton. So the guy, he can apply maximum 333.54 Newton, like before he sleeps. Okay, now let's see how much force I need to move that crate. Okay, so I'm gonna draw the free body diagram separately here. There are two different cases can happen here. One is that this one will just slide, and the second case is this one will tip. Okay, so let's say first I'm assuming that it's case A or case 1, let's say sliding. So in that situation, this is your free body diagram. Okay, so here actually the friction is, coefficient of friction is 0.2, so your F max, that would be 0.2 N. Okay, now I'll just try to see how much force I need here. Okay, so if you take a summation of Fx here, summation of Fy here, sorry, then you can say N minus 150 into 9.81, that's equal to 0. So you can see your N is actually 150 into 9.81. Right? So the F max is equal to 0.2 into N, so 150 into 9.81. So if you take the summation of Fx, then you can see P is basically equal to your P max. Which is 294.3 Newton. Okay, so you need 294.3 to move this one, but that guy can apply 333.54 Newton. So basically he will be able to slide or move that carrot, right? Now, since the first case already, is complied, so basically you don't need the second one, but just for understanding, I'm just talking about the case 2, okay? So how much force I need to tip that one. So let's say case 2, tipping. So what will happen during tipping? Actually, you will see just before tipping, you understand that this one is just gonna, this one is just gonna come out, this side is gonna come out, and everything will be concentrated only at this corner here, okay? So if you try to see that one, then basically you will see this one is actually your N, and this one will be your frictional force at this time, okay? So let's say this point is O here. So if you take the moment at O, so this distance from here to here is 1.6 meter, and this one from here to here, half of that is actually 0.6. So if you take the summation of moment at point O, let's say clockwise is positive, so P into 1.6 minus 150 into 9.81 into 0.6, that's equal to 0. Because this N and F is passing through O, that can't produce any moment here, okay? So if you try to find out your P, then this one is actually 150 is actually 551. So you can see you need a lot of more load to tip that one, because this one will start sliding at 294. So you cannot apply 551 load there because this one is already in moving, okay? So your actual answer would be yes, this person will be able to move that crate, okay? Let's move forward. Problem number 8-52, okay? This one is showing here the beam AB has a negligible mass and thickness and supports a 200 kg uniform block. So this one is 200 kg. Okay, and you can see from this dimension that actually it's working just at the middle, okay? Then it is pinned at A and reset on the top of a post having a mass of 20 kg and negligible thickness. So this one has a mass of 20 kg here. And it's asking, like, determine the two coefficient of static friction at B and C so that when the magnitude of the applied force is increased to 300 Newton, this one is 300 Newton, then basically this one will fail here and here simultaneously, okay? So you have to find out the mu at C and the mu at B for which this one will fail simultaneously when we apply that load 300 Newton here, okay? Let's do that one. So first of all, I would like to find out that how much load is coming from here. So I'll just cut it here, okay? And show that one as like this. Let's say that's at NB, and that's also NB, equal and opposite. This one has to be like this, frictional force. This one has to be this. Okay. Now here is your hinge. So if I take this one is AX and AY and take a moment at A. So summation of moment at A, let's say counterclockwise is positive. So NB multiplied by 3 minus 200 into 9.81 is equal into 1.5. That's equal to 0. So your NB is actually 981 Newton. Okay? Once you get that one, then actually I'm trying to draw that free body diagram separately here. So this one, your NB, what I got right now, that's 981. You see there is a frictional force here, FB. Similarly at the bottom I have NC, and this is my frictional force. This is the weight of that post, and this is the force working. And you can see this one is actually 3, 4, 5. That's the ratio. Okay? Now what I can do, I can just clean that part now. And if I take the summation of force in the y direction, so you can see NC minus 20 into 9.81, okay, plus 3/5 of 300 minus 981, that's equal to 0. So if I solve for that, then I get my NC is basically 997.2. Okay. Now what we can do, if we can find out, I already have NB, and if I know my FB, then basically I will find out what is the frictional coefficient at that point. Similarly, if I find out FC here, then I'll be able to find out the coefficient there. So this one is 997.2 Newton. Now if I take a moment at point C, let's say counterclockwise is positive. So you can see these two forces is passing, actually this force is also passing, this force is also passing through point C. So I have two forces for this one and this one, right? So FB multiplied by the distance from here to here, which is 1.75, and then if I dissolve that force into this component and this component, the vertical component will pass through C. So only the horizontal component, which is actually 4/5 of 300 multiplied by 0.75, that's equal to 0. So from there, you just get your FB is equal to 102.86. Similarly, you can take a moment at B and find out your FC here, okay? So, summation of moment at B, let's say counterclockwise is positive, equal to 0. So, 4/5 of 300 multiplied by 1 minus FC into 1.75, that's equal to 0. So your FC, that's actually 137.14 Newton. Now this one is happening just at the verge of failure, right? So at that time, actually the frictional force is at its maximum, okay? But we know the relationship, your F max and mu okay? So your mu is basically F max divided by N. So for here, you can see your mu would be F max, FB, what is 102.86 divided by 981. So that's actually 0.105. Similarly, if you find out your mu here, that would be 137.14 divided by 997.2, which is basically 0.138. Okay? Thank you for watching.